Hello, everyone. Welcome to the grand finale presentation of the Harmony Data Science Internship for 2023 cohorts, brought to you by Harmony. My name is Goodrich, and I am a junior data scientist at Harmony AI Labs. I'm joining you from Port Harcourt, Nigeria, and I will be your host for this session. Harmony's enduring mission revolves around nurturing a cadre of adept problem solvers via our internship-inspired approach to data-centered careers. Our pride stems from achieving this goal consistently, and it's immensely gratifying to witness the 423 interns excel in wielding machine learning cross-diverse dataset encompassing security, gender, health, and beyond. Our interns have had the opportunity to work in cross-functional teams on this, what we call capstone projects. They were assigned specific project teams to which they had to research use cases, source data sets, explore them, provide insight, build and deploy models, and are now ready to share their findings with you. In a very special way, I'd like to welcome our members of the different data science community, Harmony Fellows and Harmony Internship alumni, and our incredible interns who have made it this far. A big congratulations to you for the grit and excellence you've displayed throughout this internship. I'd also like to welcome our judges, Dr. Biodun Awojobi, who is a customer engineering manager at Google, while also holding an adjunct professorship in cybersecurity at the University of Dallas, Texas, USA. He is a multifaceted professional. Beyond being a creative technology architect and a specialist in cloud computing, he is an amiable mentor, and his favor for youth empowerment and cybersecurity is palpable. There is a word of his upcoming foundation, and the anticipation of its growth is stirring within our circles. Hello, Biodin. Thank you for joining us. We also have with us Dr. Wale Akinfadering, a data scientist at Amazon renowned for his expertise in machine learning, deep learning, statistical experimentation, and general information theory. Beyond his consultancy for startups delving into data science and artificial intelligence, akin to Biodin, he shares a passion for nurturing young professionals. Notably, he has an initiative aiding exceptional undergraduates struggling with their graduate school application fees. To the many beneficiaries of this initiative, heartfelt thanks are extended. Thank you for joining us, Wale. At this junction, I would hand over to my colleague Ade to carry on with the presentations from here on. Ade, over to you.
Thank you very much, Goodrich. Just before we go into the presentations proper, please take note of the following. Each team will have only 7 minutes for your presentation. You'll be given a warning to round up at the 6 minute 30 seconds mark, and you'll be stopped once your 7 minutes is up. If a team is not available for its presentation at its allocated time, then that team will have to forfeit its presentation. At the end of every presentation, we will hand over to our judges for their questions and their comments. You can feel free to use the comment section for your comments and your contributions. And finally, our dear presenters, try your best to be concise and straight to the point. Remember, we have just 7 minutes. And now, without further ado, we will now hand over the mic to our first set of presenters for the day. Solomon Eyetunji and Lolade Lawal of the Apache team. You now have the floor. Solomon Oyetunji and Lolade Lawal. Without wasting much of our time, we will move on to the next team. The next team for the presentation is Team Argo CD, and the presenters for Team Argo CD are Linda Owolabi and Kadamsi K. Linda
Good
Owolabi and
afternoon.
Kadamsi K. Good afternoon. You
Good
have the
afternoon.
floor. Your seven
All right.
minutes starts now.
Okay. Candy is going to share screen for me. My name is Linda Wolabi. Good afternoon, judges and the whole Hamoye team. I'm presenting for Argo CD team. Our project topic is on electrification dynamics. This means we are assessing growth patterns and the economic impact of electrification in low-income countries. We are benchmarking developed nations. Our problem statement is the electrification landscape plays a crucial role in the socio-economic development of low-income countries. Can you hear me?
I request to give access for screen sharing for Team Argo Studio. I am Kandu. I am with the ID Kandu. I am here to share my screen. Linda, I
Okay.
am here to share my screen. They haven't
Yeah,
given
please.
access for me to share the screen. Please
Okay,
give
please,
me
can you
access
give
to share.
Kandu access to share the screen, please? Please, can you give Kandu access to share his screen? Thank you. So
Yes,
please
this
let
will
me
be done
just
in a minute.
continue because of time. All right. So Kandu, I'm on the problem statement slide. Please, let's continue. So electrification landscape plays a crucial role in the socio-economic development of low-income countries. Our project seeks to rectify the problem of insufficient understanding of the economic repercussion of benefits of electrification on the growth and development of underdeveloped countries. Our project's aim is to develop a machine learning model to estimate the future economic inequality between developing and developed countries based on the level of electrification. Our objective, we are classifying the countries based on electrification status. We're exploring correlations between the electrification rates and key economic indicators. We are predicting how the economic gap between the countries will grow based on the level of electrification. We started by installing the necessary libraries for our work: pandas, numpy, seaborn, matplotlib, plotly express. We did the different data sets we matched together to get our data sets. This includes the GDP value region, income group, and country. For our EDA, we checked the shape of the data set. The data set has 946 rows and 8 columns. We checked info, we checked for missing values, there were none. We checked for duplicate values, there were none. We use the df describe button to describe function to check for statistics of the data set. So we're going to the visualization slide now. The visualization slides, that's the EDA handle. So for the first visualization, we have a pie chart. The pie chart gives us an insight. The pie chart, yes, it gives us an insight into which region has the highest electricity rates. The highest total electricity rate was recorded in sub-Saharan Africa, and the lowest was recorded in Europe and Central Asia. Second visualization, please. This is a bar chart. It gives us the region with the highest GDP. The GDP is the gross domestic product. So we are getting the GDP value. East Africa and Pacific region is the highest, and we have sub-Saharan Africa, which has a very low GDP. For the third visualization, we have the bar chart that gives us the top 10 countries with the highest GDP value. China is topping the list, while South Africa is the lowest. So this surely gives us like an idea of what's going on. So from the fourth visualization, we have a bar chart that shows the sub-Saharan Africa is the region with the highest income group. We go to the next visualization, that's the fifth one. This chart gives us insight as to what year has the highest recorded total electricity rate across all the regions. The highest year was in 2010, followed by 2011, and the list was in the 1960s. The next visualization, we have a line chart. It gives us a vivid visual as to what year had the highest GDP value across regions. 2011 was the highest. The next visualization, we're looking at the top 10 countries based on their income groups, which is divided into high, low, high, middle, and lower middle income groups. It can be seen that Zimbabwe has the highest income rate, but of the lower middle income group. So we move to the next slide, please. That's our model development. We use the ARIMA model. This is used usually for analyzing and forecasting time series data or pattern over time. And the ADF test, that's the augmented Dickey-Fuller test. This is used to determine whether the time series is stationary or not. So from what we have here, we can see that the time series is set to, I just want to explain what the time series is. The time series is set to be stationary if the series looks roughly the same at any point in time. So for this slide, we have that the ADF is more negative than the critical values at all confidence level. And this supports the presence of a unit root. So given the ADF statistics, a p-value and comparison with the critical values, it suggests that the time series data is likely stationary. So this means that the statistical properties have not changed over time. Because ARIMA models work well when the time series data is stationary. This clearly shows that our result is favorable for proceeding with, our result is favorable, right? So that means we can proceed with ARIMA modeling for our forecasting. Next slide, please. So for the next slide here, it shows that we have a low p-value and the ADF statistics is being well beyond the critical values. So this strongly suggests that the time series data is stationary. This result just shows us that our data is suitable for ARIMA modeling, and the model can potentially capture the underlying patterns in the time series data. Can we go to the next slide, please? So for our ARIMA model, it has been trained, it has been evaluated. We can see that the coefficients and diagnostic test provides insight into how well our model fits our data. The diagnosis test therefore suggests that there is room for further investigation and there is room for improvement. So the conclusion of all this is just that it is evident that our model works fine and it works accurately with our given data set. The model was then deployed using Streamlit, and we were able to derive actionable insights from it. So that's what we have here. Thank you very much.
Thank you very much, and you kept to time. Mr. Wale, can you please?
Hey, hi, can everyone hear me?
Yes, we
can
can.
hear you.
Okay, awesome. Yeah, thanks for the presentation. I think I actually need a few clarity and from this presentation. You sort of mentioned something around electrification rates or something like that.
Yes.
Can you go back and explain what that means? Because I'm saying that Africa is actually higher, and I'm not entirely sure if I got that right.
Okay, this is it. For the electrification is what happens. The electrification is very crucial to the role of the growth and development of countries, right? So being that in Africa we have like a lower electrification rate, so our income is a lot lower than other countries. What this means is that most of the time when there is constant electricity and electricity is affordable, you get to have like big companies that come in to like, invest in your country and thereby increasing the growth and gross development of your country, right? So in Africa, we tend to have like less electricity. We tend to have high bills for electricity. And this tends to, yeah.
Sorry, the rate you're talking about in this case is the dollar value, not the rate at which
Yes.
you're electrified. Okay.
No. Yes, sir.
I understand that. And then my second question is where you had like the GDP in
okay, sir.
You had GDP plus no, there's another one, the one that the GDP is Africa, right? Then the slide after this one, sorry. Okay, so you have Nigeria's GDP is higher than South Africa. So my sort of big worry with this is that you're using GDP value. I think you sort of get a much more insight from using GDP per capita. I think
Yes.
that would
Yes,
be
sir.
better, because the first thing that jumped at me when I saw this plot and I saw Nigeria and South Africa is that the GDP per capita for South Africa, I think if I'm right, is probably about 3.5 times that of Nigeria. So that basically would change this plot. But overall, I think it's sort of more of the data exploration. I like the approach that you guys have used,
Thank you.
the time series model, the fact that also what you did was actually grounded in a lot of initial statistical testing. So you did the ADF test, you checked for for stationarity of the data and all that. So yeah, good job.
Thank you very much. Thank you very much, sir.
Okay, thank you. Dr. Wale? Sorry, Dr.
Wale
Biodun.
just spoke.
Yes, Wale just spoke. I made that error. Dr. Biodun, anything for them?
And by the way, just call me Biodun. You don't have to put doctor in front of it. I thought the presentation was very good. Can you all hear
Thank
me?
you so much. Yes, we can hear you.
Okay, yeah, I thought the presentation was very good. I like the visualization and I like the processes that you took. I also had the frown when I saw the GDP for Nigeria higher than the GDP for South Africa. But
Okay.
now you know how to think about GDP. You
Yes,
know,
I will look into it.
yeah. So GDP should be is in many ways like a measure of an economy's wealth, and I think we both know how that there's some disparity in that regard. But
Yes,
overall,
sir.
great start. uh, think about how you can integrate AI models to what you're doing is what I would ask that you consider as the next step.
Okay, sir. Thank you very much. Okay, can I go off now? Thank you very much for the insights. I'm very grateful. Can I go off now?
Yes, please.
Okay, bye, sir. Thank you.
That's all for me. Who's presenting next? Because it seems like all mics have been muted.
Yeah, it should be my team, but we've not been called yet.
Okay. If you all have the access to share your screen, please go ahead and share your screen. There might be some audio.
Yeah, we don't have the access yet. We're waiting for the access.
Okay. All right. Sounds good. It seems to me like the host is back now and might just need to unmute.
Yes, I'm back. Sorry for that. It was a glitch in my network connection.
No
Okay.
problem.
Ashpant and Chiamaka, I think you have been told you have the floor now.
Good afternoon, everyone.
Yes.
So I'll be
Can I
presenting
get
on
this? Sorry. Can I get this permission for sharing my screen?
Oh, yes, I'm on that now.
Yeah, thanks a lot.
I'll just go ahead while he shares the screen. So I'll be presenting on predicting school completion rates in developing countries. In a rapidly evolving world, education stands as a cornerstone for individual empowerment and national progress, with dropout rates posing a significant challenge to global educational goals. Our project endeavors to employ predictive analytics to unravel the mysteries behind student completion rates. And that's our main problem statement to find out factors that will help to predict whether a student will complete their education or not. Then on to our aims and objectives. This is our aim. And then our objectives are one, to develop models to predict individual student outcomes, identify key factors influencing completion rates, and others. Then this is our project methodology. We sourced the data, processed it, and then did the rest, which I will discuss further. For our data sourcing, we got our data from our data set from World Bank Data Bank. This data set had the indicators for education for all the countries, but our focus was on developing countries. So we had to get another data set to filter out data for the developing countries, and also measure data set that helped us to get values for upper secondary school completion rates. These are some of the indicators or the variables in our data set. As we go ahead with it, that's the next slide. As we go ahead in the presentation, I'm going to discuss them more. Then for the data, we used the data for years 2011 to 2020, and we addressed null values. We converted the data type to the ones that we need to use. Then for the EDA, the first data we have, the first plus we have here is that of the trend for the completion rates. We see generally an upward trend for the primary, upper and lower secondary school, but the primary has the highest completion rate. The next plot here, we then went on to see the relationship between these indicators and the completion rates. Here we see a strong positive correlation between enrollment into primary school, and completion rates. The next slide shows us the pupil to teacher ratio in relationship with primary school completion rate, which shows a strong negative correlation. That is to say, the lower the pupil to teacher ratio, the higher the completion rates. The next one shows us that of the lower secondary school. It has similar relationships. This one here on the screen tells us the relationship between government expenditure and secondary schools completion rates. We see a positive correlation. That's the more government spends on their education, the more students complete their education. The next slide shows us the literacy rates in relationship with completion levels, positive correlations, as we can see also. The next then went on to wanted us to see the trend of pupil to teacher ratio over the years. So we see generally fluctuations, but in 2019, we see an increase in secondary school completion rates and a decrease in primary school completion rates. The next slide we have here shows us the government expenditure per student over those years. We see just fluctuations at around the same level, but it declined in 2018. So I'll hand over to Hash to continue with the predictive aspect.
Yeah, thanks a lot. So after the EDA data processing and all the visualizations, we were able to get three data sets. The data sets included primary schooling, upper secondary and lower secondary, right? So regression models were the most suitable models for our goals as we wanted to predict a quantity using other variables. It classified under multiple linear regression model as we were trying to predict one variable using two or more independent variables. We use different algorithms such as random forest regression, gradient boosting regression, SVR models, etc., and then compare each model's performance and their scores using R-square metric on each of the dataset. These are the evaluation on the primary schooling. As we can see, random forest and gradient boosting perform the best, and this is the plot of the best fit line that we were able to plot for the models. We then compared we then compared it for the lower secondary schooling. As you can see, again, random forest and gradient boosting performed the best as well, and then we plotted the best fit line for these models. The next was the upper secondary data set. As we can see, random forest and gradient boosting were the best models, and then we plotted the best fit line for these models, right? We then compared each model's performance and their scores. The best models that we were able to find out were the random forest and gradient boosting. The image here shows the feature importance from the best models. We plotted feature importance so that we can understand the primary features, as this gives us the reason why the students are dropping out. So right, this is the primary feature. This is the feature importance on the primary dataset. As we can see on random forest, the net enrollment played the most important role in model training. But in XGBoost, we can see that people to teacher ratio played the most important role. For the lower secondary dataset, we can see the net enrollment played again the most important role. And in XGBoost, it was trained teachers in lower secondary education that played the most important role in the dropping out of student. The the last dataset, that was the upper secondary dataset, we can see that on both the models, the main feature was educational attainment, the graduation, right, that they were able to attain. So from these, we were able to reach a conclusion, right? This conclusion was that we were able to find out a reason why uh, behind the dropping out of students. The noble correlations were identified, such as positive association between enrollment rates and successful completions. Additionally, factors like literacy rates, education attainment, and government expenditure emerge as significant contributors to completion rates. Uh, for future scopes and recommendation, it includes considering other factors and combining more data sets and more features, and then training the more complex models on that data. Our research was very basic as we weren't really able to do a deeper root cause analysis, but this suffices as a stepping platform to conduct further research on the same topic. These are some of the recommendations on how to use this research we perform. We can use it for targeted interventions for direct different education levels. We can also use it for literacy enhancement programs, as well as uh, to make focused education expenditure. Well, this is our team, and thank you so much for listening to us. we are open to questions now.
All right, thank you so much for that presentation and keeping to time. Okay, so
Mhm.
I'll be calling on Dr. Wali to take the floor first.
Um, yeah, I think this is good. Can you go to the feature importance plot?
Right. Yeah.
Okay, so we'll look at the X3 boost. The pupil to teacher ratio is okay. So that's primary. Okay. Interesting. So that's actually one of the biggest reasons. And then
Mhm.
the adjustment net error. Okay. Yeah. So I know at the end of the presentation you mentioned that, oh, maybe this research is basic. Actually, I don't think it is. Because this is, in sort of developing economy, this is the kind of research that probably the Ministry of Education or the presidency would need, if they want to have sort of interventions to to actually stop people from dropping out from school. So that this is good. And where's the data from? I was wondering if you have, any sort of geographical location, like are there did you do any exploration to look at countries where they have the highest amount of kids dropping out, for example?
Uh, I think the data was sourced from the data bank, like the World Data Bank, right? But
Mm,
it contains the data. It contained the data of all the countries. But
okay.
we decided to go for the developing countries as it was a more concerning issue to understand why there was more dropouts in the developing countries. I don't think we were able to do a geographical analysis on the data. I think this will be on future considerations as well to do a geographical analysis on why which countries faces the dropouts more. Yeah, but yeah,
Yeah.
our data set included for the whole world, right? It included all
Okay.
the countries, but we focused it to developing countries.
Okay. All right. Thank you.
Mhm.
Thank you,
All
sir.
right, thanks a lot.
All right, thank you for that. Dr. Biodu, anything to add?
Oh, in just to follow up on what Wally had mentioned, I actually think this is a good a good project, and I like the outcomes that you brought out. Out of curiosity,
Thank you.
what are like the next steps that you all are planning? Like, what do you want to do outside of this?
All right. So I think we will take into the consideration that Dr. Wali mentioned to consider geographical features as well. The next steps would obviously include including more data and including more features into the research, as we were only able to get only three data sets. So yeah, obviously just making it large enough to that it covers the entire, like it is not specific to certain reasons. Uh, so yeah, I think the future scope would include to extensifying the research to different reasons.
Okay, I mean,
Mm-hmm.
an example of the type of data set you can include was what Wally had mentioned around like geographic data. If
Mm-hmm.
outside of that, the from the presentation that happened earlier, there
Mm-hmm.
are commonalities and even synergies with GDP per capita. There are synergies with like income and
Mm-hmm.
per region. So those are like areas where you could continue to dive a little bit deeper. So if you get like the income for a specific location, if you get like GDP per capita, if you get crime rate, all of this can help whoever has access to the refined data opportunities to make sound decisions. I'll give you a small
Mm-hmm.
example. So say for example, say I'm the governor of of Lagos State, and I have budgets for education, but I don't know where I need to channel my budget. If I have crime data, if I have income data, if I have dropout rates, if I have like, hey, here are like a bunch of approvals that we have for factories in specific locations, I could use the inferences from a lot of this analysis that you all have done to decide, right, with this information, this is where I should be channeling my resources. Because if I do, it's going to lead to positive results for the folks that live in the areas that I'm channeling my resources to. Do you get what I'm trying to drive at?
Yes, yes, sir, we understand.
Yeah.
Yeah, so
Yes.
there is immense potential for the project that you're working on, and immense opportunity for you to continue to include additional data sets. And then maybe when you're done with that, you can publish something. You know, you can do something that's local to where you live, and you can publish something, put it in the face of someone who could pass that along to the right person. But
Right, sir.
overall, great job.
Thank you very much, sir.
Thank you so
Thank
much.
you.
Yeah.
Okay, thank you for that. The next team to present is Team Ion Flux, and the presenters for Team Ion Flux are Eloho Opako and Yusuf Okunlola. Eloho Opako and Yusuf Okunlola, you have the floor and your 7 minutes starts now.
Okay, thank you. Please, can you allow me to share my screen?
Yes, you can now.
Okay. Just a minute. Okay. Hi, everybody. My name is Elo Okpako, and I'm here with my colleague Yusuf, and we are doing a presentation on the climate change analysis in West Africa. We are forecasting the temperature trends for different years, and these are the team members that participated in this. And this is the table of content that will be following for this presentation. So we understand that Africa is especially unique because of our climate change and because of the position of the continent in relation to the equator. So for this project, we chose West Africa, and we obtained data sets for over 42 years, since we can use this data set to understand the climate change that has been happening across the years in West Africa. And we aimed to forecast the temperature change for following years after the years that we obtained for the data set. So these are the objectives of our project. And like I said here, our aim was to develop precise area-based temperature forecasting models using the historical data. This is the methodology, the flow of our work. And for the data analysis part, we obtained the data set for this forecasting from the National Climatic Data Center, NCDC, and we obtained data set from the years 1980 to 2022. We did a lot of cleaning and changing. We dropped stations that had less than 30%, that had more than 30% missing values, and we filled the ones that had less than 30% missing value using a backfill and fall fill method, since it was a temperature and time series data. And we also converted the temperature from Fahrenheit to centigrade. So this is a representation of how the data set looks like. So in the analysis, first of all, we did was to observe the average temperature change in the countries in West Africa. From here, we can observe that most of the countries located towards like the Atlantic, they had like a relatively lower temperature compared to those that were located a little bit closer to the Sahara, probably because of the position in relation to the equator. And we also try to see the average change in temperature across the years for all the stations. And we can see here that the temperature has remained relatively constant with just slight fluctuations from year to year. So on the average, the temperature is slowly rising, but it's not really noticeable. So we try to see, okay, so it's not really changing on the average for all the countries, but what happens like if we check for each individual country? So from here, we can see that for each individual country, it's actually changing, which corresponds with the first analysis that we observed. And we can see that here for each of the countries, it is different. And yes, so I'll hand over to my colleague who is going to talk about the modeling.
Thank you so much, hello. Good day, judges and team members. So going forward for the data modeling aspect, we had to check for the data stationarity, and we made use of the augmented Dickey-Fuller test, and we could see that the p-values were less than 5%, and there was also a stronger negative ADF test value, which implies that the time series data set over the years was stationary. Going forward, we implemented 3 models. For the modeling, we made use of the vector autoregression model, which is the VAR, the HARIMA, as well as the Facebook Prophet. Next slide, please. So going forward, we could see the comparison charts for the HARIMA model, how we compared using the test value as well as the predicted value, and the HARIMA as well as the Facebook Prophet models did well. And for the vector, the third model, next slide, which is the VAR. Okay, so for the VAR, we could see that there was really a little change for it, but one thing we observed was that it had a low computational time for training for all the stations, and due to its multivariate nature, which allows us to model all stations simultaneously, we implemented the VAR model for our model deployment. The chart also shows the evaluation metrics, which implies that the HARIMA model as well as the Facebook Prophet models did well. So next, the project shows, next slide, how climate change has affected various countries in West Africa temperatures for the period of 42 years. And temperature trends also shows that some areas are stable while others are getting warmer. So the next slide shows the deployment of the model, the VAR model, which can be seen on the screen here. So the model, as I earlier mentioned, is multivariate in nature and allows us to select multiple stations at a time for computation. So that's the overview of the data set. So we can select various stations across West Africa and then input our lag value as well as the number of years to forecast, and we are going to get the forecast overrun. Okay. All right. So going for the recommendations, we intend to add more. We intend to add meteorological variables like humidity as well as rainfall to have a holistic view of the climate patterns, as well as implementing other algorithms, and also emphasizing the practical applications of the findings for tailored interventions in the areas of agriculture, as well as resource allocation. Thank you so much.
Okay, thank you for that presentation and for keeping to time. Dr. Biodun, you have the floor first on this.
All right, well, great job. I enjoyed the presentation. I like the fact that you created a demo that backs it up. Just a few questions. What's the next step for you all in with this project?
Thank you so much, Dr. Biodun. We intend to generate the forecasted values for the stations for up to like 10 years using the HARIMA model as well as the Facebook Prophet. Due to kind of time constraints, we couldn't come up with this. So we intend to go forward with that, as well as based on the feedback, we also intend to work on it and publish the work soon.
Okay. If also that, and that's good. If I may ask, to what was the most challenging part of this project for you all?
All right, the most challenging part was, okay, Elo, do you want to go?
I think it was the back and forth that we had with like the data set. That was actually, it took a lot of time. That's why we didn't have enough time to work on what we would have wanted. Like for this forecasting that we had, we also thought that it would have been nice to show like certain months that had like fluctuations in temperature more. And then we could also try from the data set to see the factors that affect the temperature, like maybe elevation of the countries and other factors. So because we had very short time, we couldn't implement all these stuff, and that's why we had to make it as basic as possible.
Okay, that's good. If you could add additional data points to what you have, uh, did you consider more of like air quality as another angle that you can include into this year forecasting?
Yes, we consider air quality. We also consider like maybe the precipitation of the countries and all other like atmospheric data that can be collected, but we just try to like make it basic, and that's why we just stuck with temperature.
Okay. Yeah, my final question is from a did you guys ever like try using any of these AI models to actually generate data, or that was out of the scope of the work you were doing?
And it was out of the scope of the work. Like I don't know if I understand you correctly. Like, did we try to generate data for the stations here, or we obtained this data directly from the website?
Yes, did you so I don't know if you all know this, but you can use models to actually you can trick models into generating data. And
Oh,
what I'm asking is if you consider that as like another way to enrich the data set that you have here currently.
no, we didn't consider that for the analysis.
Okay. I love everything you've done. I love the fact that you have a site that's viewable. What I would recommend you do is write about it, and you all should continue to meet as a group, look into how you can continue to evolve what you have done. Everything you have here can easily become a company. Like everything you've created here, with the right extra data set or secret sauce. Maybe there might not be a secret sauce, but there's secret sauce in anything that has AI recently. So you can start thinking about that as like your next project. How can you enrich what you have now? How can you add value to organizations proactively? But yes, there's a potential for a company for from what you're doing right now.
All right, thank you so much.
All right, I'll pass it on to the next person. And it seems like it's Wale speaking next, right?
Yes, please.
Yeah, it's me, but I don't think I have much to add. I think Bill already mentioned everything, which is it's good that you guys have this web app, but I I would have sort of expected to see more. So which is maybe using other data set, having ways to, for example, maybe even tie this to um um maybe tie like temperature to maybe social political unrest, for example, maybe terrorism, because sometimes, or maybe tie it to climate change, right? So that those are some of the insights I would expect to see, and I think in the future you guys can enhance it by getting more data set and sort of thinking about some of the critical things that you can use this to help or aid. Thank you.
Okay, thank you.
Thank you.
The next team to present is Team GitOps. You guys did not submit your presenter's name. Are the presenters for Team GitOps around? Seems they are not around. I'll be moving on to the next team. That's Team Iroku. So the presenters for Team Iroku, Jane Imoke and Abdulaziz Shakula. Jane Imoke and Abdulaziz Shakula. Jane Imoki and Abdulaziz Shakola.
Yes, I'm present.
All right, you have 7 minutes and your time
Okay, please, can I
starts
be
now.
given the permission to share my screen? I have no permission
Yes,
to
you
share
can
screen.
share your screen now.
All right. All right. Can everyone view my screen?
Yes, we can see your screen.
Okay. Good day, everyone, judges and my fellow interns. I am Jane Imoke from Team Heroku, and I'll be speaking on remittance patterns and economic development in Africa. To begin this, we carried out some research and observed that global increase in remittance was over $700 billion in 2021. With that finding, it was realized that remittances serve as a vital counter-cyclical safety net. That is, it provides financial stability during economic downturns. We also found that remittance plays a crucial role in poverty reduction by providing direct financial support to families in need, contributing to improved living standards and economic well-being. However, some challenges to this were sustainability, unequal distribution, and other potential negative impacts like inflation. Hence, the problem statement. Gaps in current understanding of remittance economic development link, limitation of former teams, buys, and cat boost methodologies, need for tailored research focusing on Africa, especially post-COVID-19, Brexit war, financial crisis in 2008, and so much more. And Dr. Wale Akinfaderin's insights on the importance of context-specific research. Our objectives to address the problems are thus. This is the First off, to investigate the impact of remittances on economic indicators, analyze the effects of COVID-19 on remittance flows, and improve upon previous methodologies for deeper insights. This is the brief overview of the project process. We first off began with sourcing for our data from reputable archives such as FDI and GDP. Then we cleaned the data to ensure missing values were properly handled and the data had consistency. Finally, we simmed down our data to just African countries, which was our point of focus. And each African country was aggregated to each year to facilitate a comparative and consistent analysis over time. Next, we carried out exploratory data analysis, and below are some of the observations made. As you can see here, for the remittance trend, there is an increment from 2005, and a major upscale was observed in 2020, being the COVID year. These are the other graphs that were generated from data analysis. And as you can see here, the impact of the COVID-19 pandemic was specifically examined by dividing the data into pre-pandemic, during pandemic, and post-pandemic periods. This analysis provided insights into the immediate and lasting effect of the pandemic on remittance behaviors. And from BARD AI, scaling the effects of COVID-19 on remittance was predicted to be 70% scale with effects of up to 2 years. Brexit has just less than 10% of the effects on remittance received by African countries, and financial crisis in 2008 was within 10 to 30% scale for 1 to 2 years. Now, my fellow group member, Tizis, will be taking on the model evaluation phase of the presentation. Tizis, please, you can carry on now.
All right. Thank you very much, Kevin. Hello, everyone. So what we did, we tried to examine the data and try to look at how we can feature engineer, looking at the GDP per capita ratio and also the ratio of remittance paid to remittance received. And then we tried to create a model that is able to remittance African countries. So the remittance we're talking about is remittance inflow within a certain African country. Then we look at different models, such as the light GPM and linear regression, as well as go to the next one. Oh yes, and so as well as the good sensitivity. And then we realized that after our model evaluation, the LGBM model was actually the best with an auto score of 0.
Sorry, we can't hear you anymore.
All right, so can you hear me now?
Yes, we can.
All right, so we realized that the LGBM model has the best
Yes, we
auto
can.
score of 0.8. All right, so, and then some of the findings we had was the fact that so some of the findings we found out was that we needed. Okay, so the COVID-19 pandemic was not a negative effect on the number of remittance inflow. And then we also used migration to check if there was actually a correlation for prediction of our model. And then there was actually a high correlation. And then we also tried to do some prompt engineering by looking at how AGI can actually help us to scale effect of crises like the financial crisis and COVID-19 on remittance inflow. And then there were cases where the scale was about 10 to 30%. And yes, so, and I think that was that. Please, next, please. Next.
You have 30 seconds more to round up.
All right, so some of the limitations of our model was the fact that we're not able to explore much more model like the ARIMA or trying to select best differentiators for our model. And then we're not able to explore other efficient model like Prophet due to some contingencies. And yes, so I think that is that. One of the ways in which we can use this model is to help governments predict the amount of remittance inflow for their country, especially in Africa, where a lot of families depend more of inflow for consumption. Yeah, thank you.
All right, thank you for the presentation. Dr. Wale, you take point on this.
Okay. So the title, one of your conclusion is that this project offered a comprehensive view of how remittances potentially impact economic development in African countries, especially in the context of external shocks. I don't think I've seen that, right? Okay, I know you guys have, you have some data where you're sort of modeling what the flow of remittances are, but I'm also a little worried that there is no sort of qualitative. I mean, there's a conclusion, right? But the conclusion doesn't map to any aspect of your analysis, right? So there's no sort of this qualitative conclusion. So, for example, when you build your model, what are some of the biggest factors that you see that are actually impacting the flow of remittances? What I don't know if you guys are getting what I'm trying to say, right? Can you sort of offer more, just give some more information around some of your conclusions?
Okay, yes. Like I said before, that remittance is actually I think the remittance inflow is actually what majority of families, especially in developing countries in Africa, actually depend on. And as you can see, the more the migration, the higher the inflow of remittance, and that could actually tell you that economic development in a country can be tied to the number of migrants that actually leave a country compared to the ones that come in. And then we are trying to create a model such that when deployed on a platform, it can help you to predict the amount of remittance that is possible. So you can tie remittance to remittance inflow as a metric for determining economic development in a country. However, we actually had plans to make something much more robust in the sense that we wanted to look at how we cannot just use remittance alone, but determine the stability of exchange in a country. Like GDP could actually be something that can tell if an economy is growing. However, development is something that GDP per capita will look into, and then the same thing is applicable to remittance inflow. Yes. So if yes, so if you can
let me
yes.
So I wanted to just go back to the point, right? Is that yes? I mean, if as the number of people leaving the country goes up, I think definitely it's pretty straightforward to identify that the amount of remittances, will definitely go up, and then countries can plan around it for the FDI. But sort of my question was in that conclusion, right? Like in your research, there's nowhere where I've seen things around, because you talked about also planning for things around the COVID-19 and pandemic, right? In your data and the information you have, did you see some outliers, for example? Did you think if you normalize the data based on the number of people leaving the country, are you seeing an increment during COVID pandemic or not? So for me, it's more like so that's my major concern. I think this is great work,
yeah.
but the conclusion doesn't really match some of the research I'm saying.
Okay. Yeah, I guess it was due to the fact, like I said, that we're actually planning something robust. However, so some of the things we're actually coming up with was actually based on what we've worked with currently. So so according to there's a data visualization on the slide which actually talks about how remittance has actually increased in Nigeria. We were more or less like using Nigeria as our focus, a much more concentrated focus. Okay, then we see that yes, indeed, remittance has actually increased as well as migration, and then we could also see that foreign investment has actually increased as well. There is a correlation based on the slides we have. I'm sorry, we could not really give in that. Yeah, exactly. So there is a correlation based on the data we have about how the FDI has actually been able to impact remittance inflow as well as the GDP per capita ratio. Yes.
Yeah, but as the GDP per capita really increases, I mean, I think I'll probably stop soon so that my other colleague can give feedback, because the conclusion from this is that yes, as people leave the country and they become immigrant elsewhere, you actually get more remittances, and then it's probably good for the country. But actually, the opposite has been the truth, because a lot of people leave because of harsh economic conditions, right? They want to make it out there, and then in some of these countries, they sort of continue to plunge into more penury, right? For example, the instability of the naira, for example, or even other countries in Ghana also, right? And so it seems like the opposite of what you're saying is actually the reality. But I think that's something that you guys should also sort of, just do more research around, the economic conditions and see what actually is the real causal effect of higher remittances. Because eventually what happens is that people leave because of the economic conditions and things continue to get really bad. for example, the devaluation of the naira, people continue to send money, and then exchange rate also goes up, and then the currency becomes sort of more unstable. So that's another angle that you can look at it.
Yes, thank you very much. We actually got to make a research around that, but it wasn't, we could not cover it due to, we couldn't cover the scope due to the data we have, in the sense that most of the remittance that actually come in aren't for the purpose of investment, but rather for the purpose of consumption. And that is why there isn't really no difference as regard the standard of living of the people in that particular country. Yeah.
Okay. Yeah. Thanks a lot. Thank you.
Yeah. Thank you very much.
All right. Thank you for that. Dr. Biodun, any comments to add?
You might be on mute if you're speaking.
And yes, I was. Thanks Wale for drilling a little bit deeper on this topic, because I had similar concerns regarding remittances, and there's so many. When I look at the topic, yes, this is more of a data centric approach that we're taking. But when I look at the topic, I realize that yes, there are quantitative reasons and there are also qualitative reasons, and there are also many variables that come together to say, hey, this is the true why remittances are happening or remittances are not happening. From everything you presented, it still seems to me like it's still hypothetical for now. What I would suggest that you do is maybe you all should come together and brainstorm on, oh, there are a bunch of like, what are the very many other factors? Some people leave and they're like, I'm selling everything that I own in this, my current home country. And when I move over there, I'm not planning to come back. You're not going to see remittances in that situation. At least not at the pace of investment. It's just purely consumption. And you also see cases where some people will say that, hey, I'm traveling, but I'm going to be back, so I'm going to do remittances, but my remittances is only going to be to try to get the next batch of people I want to get out. A country that only consumes but does not produce would never actually, while the remittances will go up, will never actually grow. So the GDP per capita angle, I think that needs to be redefined a little bit. I did hear you say you did a bit of prompt engineering and AGI. I don't know which AGI you're using, but I would love to test it out. But overall, I think this is an ambitious project, and I think there's a lot of promise, but there still needs to be a lot of like qualification on, okay, what's our step one? Our step one is to actually say that, okay, we have 3 variables that can build to point A. Step 2 is we are improving on these 3 variables and adding one more variable that's now credit worthy of, like, this is where we really want to be. There needs to be that journey in what you're doing. I don't completely see it yet. But overall, I'm glad that you're trying to come up with multiple narratives around this, and it's definitely a work in progress. So continue working on it.
Thank you very much. Thank you.
Okay, thank you for that. The next team to present, that's Team LLM, and Bamidele Taylor, you are the presenter for Team LLM. You have the floor. Your 7 minutes starts now.
Can you hear me?
Yes, we can hear you.
Okay. Can you all see my screen, please?
Yes, we can see your screen.
Okay. Good day, judges, and good day to my fellow interns. The name of our project is Effects of Socio-Economic Factors on Malnutrition Among Children in Africa by Team LLM. Nutrition plays a very important role in the nurturing of every child, and malnutrition is a difficult challenge in Africa, as it is the second leading cause of death after malaria. Our project analyzes the effect of socioeconomic factors like education and income in Africa. For our progress statements, we aim to address the significant issue of malnutrition in Africa, specifically by analyzing and to investigate factors on child malnutrition in North America, in North Africa, West Africa, East Africa, Southern Africa, and Central Africa. We aim to review the regional variations in malnutrition burdens through extensive time series analysis and forecasting. Our processes include data collection. We got our data from the UNICEF data warehouse where we had to query the database for malnutrition indicators, dietary intake, education, and income level from 2001 to 2022 for African countries. Then we did some data cleaning processes, addressing the data type issues, missing values, and duplications. We focused on extracting African countries and grouping them by regions. We investigated child malnutrition markers across factors like maternal education and income levels in African regions. We explored different visualizations. And we also employed two model forecasting for the child malnutrition. We have employed the seasonal autoregressive integrated moving average, that's SARIMA, and Facebook Prophet. This pie chart here shows the effect of maternal education on child malnutrition. Here we see that at 4.4% of child malnutrition suffered across Africa are due to non-educated mothers. And we also see that 18.3 of educated mothers that have gone through tertiary education also suffer from child malnutrition. That's for severe wasting. For underweight, we see that uneducation affects underweight by 38.4%, and only 10.4% of educated mothers actually experience underweight in child malnourishment. Here we look at the different African regions, and we see that stunting is the most prevalent malnutrition indicator in Africa, with East Africa being the highest malnourished region. We also see that overweight is the least, is most experienced in North Africa. And we also see that severe wasting is least experienced malnourishment across Africa. Here we analyze the trend of underweight across African regions from 2001 to 2022. And we see that Central Africa and West Africa suffer the most from underweight, with North Africa suffering the least from underweight. Here we analyze the correlation or the association between breastfeeding and stunting. And we see that the bubble chart illustrates that while there is a high percentage of breastfeeding across most African regions, there's also a wide variation in stunting rates, with North Africa showing notably lower stunting rates, South Africa having both stunting rates and breastfeeding percentage compared to other regions. This bubble chart indicates that breastfeeding rate increases. There's no clear trend in overweight rates across different African regions, with most regions showing a mix of lower and higher overweight rates irrespective of breastfeeding percentage. Here we showcase the model evaluation of SARIMA and Facebook Prophet. We use SARIMA as the baseline model due to its robustness and the ability to handle various time data. Facebook Prophet also is designed to handle inherent challenge, which is well suited for our dataset due to its irregularities in the child malnutrition indicators. But to assess the forecasting performance of models, we use the RMS and mean absolute percentage error. That's RMS meaning root mean squared error was used, and we see that though SARIMA performed really well, Facebook performed just slightly better than SARIMA across all regions. We also forecasted the different child malnutrition indicators, and we see that Central Africa we see that there's a general decline in child malnutrition across African regions. We experience some spikes in overweight in South Africa, and we experience spikes in stunting in East Africa and West Africa. We also experience spikes of underweight in East Africa and Central Africa. For wasting, we experience spikes in East Africa, Central Africa, and West Africa. But overall, there's a general decline in child malnutrition in years to come. For our conclusion, we see that higher malnutrition in children is linked to mothers with no education. We also see that children of mothers with tertiary education are more likely to experience overweight than other types of malnutrition. We see the higher rates of stunting and underweight occur in Central Africa and West Africa, which have low-income countries. We also have lower cases of malnutrition in Northern Africa compared to other African regions. And overall, there's a general decrease in malnutrition education over time with potential future spikes. For our recommendation, we advise to focus on increasing educational opportunities for women to reduce child malnutrition. We also advise to implement targeted nutritional interventions in higher malnutrition areas, especially for children of less educated and low-income mothers. We also advise that we should address poverty through economic support and education programs to lower malnutrition rate, and also apply successful nutrition strategies from North Africa, since it's the region that performs the best among all other African regions. We also advise that you should set up systems for early detection of malnutrition spikes and ongoing monitoring. And we also advise to promote nutrition awareness by conducting campaigns to educate about child malnutrition and healthy feeding practices. Thank you.
All right, thank you for that presentation. Dr. Biadun, you have the floor on this.
Yeah, I like the presentation. Do you mind moving back like four slides to the back? Okay, and you got your data from where again?
UNICEF data warehouse. We had to query their data set.
Okay. All right, cool. What was the most challenging part of the project that you concluded?
Acquiring data sets. Getting data from the UNICEF, getting specific data from UNICEF website that was applicable to Africa was very, very hard. We had to download and re-download and analyze and drop a lot of values, and getting the data set was very hard.
Okay. Well, if there's any takeaway that I'll share with you,
yes, sir.
I know you got in the data set, but now there are synthetic ways to generate data sets using a lot of the models that are now out there, the AI models that are out there, and you might want to start exploring that as an option going forward, because those are like data sets that are so rich, already pre-cleaned in many ways compared to a lot of the data sets that you have access to. So, well, overall, I thought the presentation was good.
Yes, sir. So please, I wanted to ask, this synthetic data set, are they applicable to real-life scenarios?
They are. I mean, a lot of the data sets, any model that's created, in many ways, how models are created using human-generated data.
Yes,
most
sir.
of the models, say ChatGPT as an example, there will be data sets from Quora, from Reddit, data set that humans have already kind of pre-populated, but then combining all of that data set to build out the model, then you can trick that model to spitting out the data that you're looking for.
Thank you, sir.
Okay, thank you for that. Dr. Wale, any comment to add?
Yeah, so I think this is a good presentation. And I think the modeling aspect of it, sort of using first Sarima where you're considering seasonality, and then you're also sort of using Facebook profile. It's good. However, I've been pondering and I've been looking at the slide, and I'm surprised. And I'll tell you why. So you could, if you look at Sarima and every profile, right? Just let's look at the MAPE numbers, which is sort of these error values, and almost all the results from Sarima are not exactly great. However, the idea is that Facebook Prophet, because in the Facebook Prophet now, you're going from an autoregressive model to sort of a model that actually uses the GAMs, the generative additive model, and should be better. But in some cases, I'm seeing where the Facebook Prophet is actually doing worse than the Sarima. Central Africa, for example, if you look at overweight, the error rate, the MAPE is 99.42%, and then for Facebook Prophet is 273%. So there's some cases where Facebook Prophet improves a little bit. There's some cases where it's just really bad, and that is a little bit surprising. And it comes to my next question is that, how many years of data do you have? What is the time frequency that you were considering when you developed this model?
We made use of data sets from 2001 to 2022, okay. And the time frequency was a yearly frequency.
Oh, okay, that's why. Okay, so it's yearly frequency. So you basically have 14, 15, no, sorry, 2022 data point. Okay, that's why. And then you're using maybe the first 15 years thereabout to train.
Yes.
And then the last 5 years to test.
Yes.
Okay, so it's a data point problem. So I think I'm right then. Yeah, to be honest, I don't think we can conclude anything with that kind of time frequency, which is yearly. I think the error rates are really, really large, and you could go back to where you had like this plot, this really nice plot that actually shows. Can you go to maybe the next slide or the slide before? Like a lot of plots.
Okay, the forecast.
Yeah, the forecast plot, right? And you could see how large, so the shaded light blue, right, which is the uncertainty, you could see these are really, really large. And I think these actually stem from the fact that you don't have a lot of data set. So I think, to improve this and to have results that are probably more reliable would be, I think one of the things you can do is maybe get much more granular data or get more data set. And I think that would help improve your forecast. Another thing also is that, which is a very, very good suggestion from Biodo, is that even between the timestamps that you have, right? So you could say, I have from 2000 to 2001, or from 2005 to 2006. Can I actually create synthetic data to fill in that gap, for example, based on some other factors? And there are a lot of recently like GenAI models that you can use to help create synthetic data that you can use to test your model. So, yeah.
Yes, sir.
All right.
Thank you so much.
Thanks
sir.
again. You're welcome.
Thanks, sir.
Okay, thank you for that. So now we'll be circling back to Team Apache. You missed your presentation earlier. Solomon Oyetunji and Lolade Lawal. Solomon Oyetunji and Lolade Lawal, are you guys around for your presentation?
Yes, sir. Yeah, good afternoon, sir. Can you hear me, sir?
Yes, I can hear you.
Okay,
So,
sir. Yeah. We are available for our presentation. But
yes.
sir, Umar Ahmed is actually filling in for Lolade because Lolade said she's having issues. So we've notified them on the group about the changes.
All right.
Yes, sir.
Yeah, no problem. He has been made a co-host and can share his screen. You have 7 minutes and you start now.
Okay. Yeah. Good afternoon, everyone. My name is Oyetunji Solomon. So we will actually be presenting for Team Apache. The topic of our presentation of our project is further improvement on animal species detection using deep learning. So our team includes this shown on the screen. So I and Umar Mohammed will be presenting. So our problem statement. Our problem actually aims to enhance object detection, counting, and classification model utilizing the YOLO model for efficient bounding box drawing. And also we'll be addressing variation in size, appearance, and environmental conditions. Like the team, we actually aims to provide a robust solution for tracking and classifying a large number of animals simultaneously in live video streams. We got our data from Cargo, and the data set name is animal image data set. And in the slide there is the link to this data set, and the size is of about 686 megabyte MB. So the data set actually contains 5,400 images with 90 different animal categories. So, okay, I will be starting from here, like continuing from here with the introduction. Like deep learning based object recognition algorithm have become crucial tools for identifying and classifying animal species. So the project actually focuses on utilizing advanced neural network architectures, including convolutional neural network and techniques like YOLO, you only look once, to count instances, classify animals, and detect live animals in real-time environment. So the model developed not only aid in species identification, but also contributes valuable information for habitat monitoring, behavioral analysis, and understanding species distribution. Okay, so we actually have some teams have actually worked on this project before, like animal detection, but the studies was made by actually team OpenCV and Light, and GBM laid the groundwork for the project. When they did it, they used data sets such as African wildlife, danger of extinction or animal image dataset, and animal detection images dataset. So we are actually building on what they've done, and it is to the extent that we are able to use YOLO to be able to identify animals faster, even in live video streams. So we did our data inspection and review. We made a display of some images up to 9 classes, and we'll be showing that now. Yeah. So we use Matplotlib to visualize some of the images in the data set, which include this. And then continue from there. In our data preprocessing, we actually load the data set, we size and normalize, and then we split the data set into training, validation, and test sets. So it also saved the preprocessed images to their respective directories for further use in model training, like in our data processing. And the number of images in each set is counted to ensure a balanced distribution. In our model training setup, so in setting up our data, like in setting up the data generators for training, validation, and testing deep learning model, we use image data generator for data augmentation during the training to actually enhance the model's ability to generalize. So this actually includes the code to it. So then moving on to this, we actually did baseline model architecture, of which my partner will actually continue from here and explain further. So I will handing the mic to Mohammed.
Yeah. Good afternoon, everyone.
Yeah,
So
good
from this
afternoon.
visualization that we have in the training result, as you can see, in the loss section, the graph keep decreasing. This is to indicate that our model is learning and improving its ability to make predictions. And in the loss section, the training section, sorry, the model keep increasing, and this is to show that it is also getting better at predicting on the training data set. This is the result that we have after implementing the model. As you can see, the model is detecting the animals live, and it's also counting the number of objects, animals on the video. Can you go up small so that it will show the number of the animals? No, not here. On the slide, on the notebook.
Okay. It's not
on the notebook. Okay, we updated the notebook. This is a previous video. That notebook was counting and showing the total number of animals on the frame. So I think my colleague did not open it on the GitHub. So, and it's identifying the animals live from the video frame. Yeah, open it from here. We can see all this thing. Just click on the other slide, on the other tab.
Okay.
Yeah, click on the other tab.
Like something is actually blocking.
No, we can see your screen. You can see your screen.
I know.
You have
Like
30 seconds more.
Okay, okay.
Okay.
Oh.
So
Let's just continue the presentation.
Okay, so what we observe is our validation accuracy keep increasing and the validation loss also keep increasing. So in conclusion, our team undertake a significant initiative to improve on animal species detection and classification using CNN model and YOLO object detection. So we utilize an animal dataset from Kaggle that consists of 5,400 images with 90 different classes of objects. So to further improve on this model, we need to expand the training dataset and explore more additional techniques to handle diverse environmental conditions. Thank you.
Thank you very much for that. Dr. Wali, your comments.
What YOLO version did you use?
It's YOLO version 3, sir.
Okay, V3. Can I see your metric again for this project? Your evaluation metric. Go to side. You probably don't have it here. Okay. I'm actually still confused. I'm a little bit confused around. Are you doing a classification model or a detection model or object detection model or both? Which one exactly?
There is object animal classification and identification.
Okay, so then why are you using YOLO? So that's what I don't understand, right? So the idea around YOLO is sort of this object detection where you're identifying animals in an image or in a frame, and you can maybe identify one animal or multiple animals, but again, you actually draw bounding boxes around it, right? And so you use both the coordinates of the bounding boxes and the sort of classification accuracy. You combine that to form. So that was why when I was hearing metric around accuracy for object detection, you don't actually use accuracy. You use your mean average precision. Now, your mean average precision is a combination of getting the bounding boxes much more accurate, which is this IOU, intersection over union, so multiplied by the ability to classify. So that's one thing I'm not entirely is that, which model exactly is giving you this result, and are you sort of detecting, or are you only classifying? If you're only classifying, I don't think you would use YOLO for that.
Yeah, we're identifying and identification and classification of the animals. So we use a pre-trained model, inception model with our data set to.
Okay, so that's a different model. That's a different model entirely, not YOLO. So using the inception V3. Okay. So that's the first thing. Okay. So the second comment that I would make is that we've seen a lot of classification of animals, right? There's a lot of cargo data set around it, right? So my question is that what exactly is it that your team has done differently, and how do you envisage anyone, using this in the future?
Yeah, what we did is we got a data set apart from the one from ImageNet, and we train it and we improve on it, on the accuracy of the model. And from the GitHub link that this my colleague is supposed to open is counting the total number of animals on the frame. So even if the number of identification on the frame will be counted, so we know the total number of animals in the frame.
Okay, so you can count it. Did you implement that? Do you have an example?
Yeah, we have it, but we are having
Did
a
you?
little.
Okay.
Yeah. Can you open the Solomon?
So
Open the
because the other
link.
thing also is that if you're counting the animal in a frame, precision matters, right? So for example, I'm thinking of there's some people that are maybe they work in like a wildlife camp, not even wildlife camp, even people that are that maybe they sort of rare animals, for example, right? They have drones, they have cameras, they want to make sure that they can take stock of all the animals that they have, and they can count them regularly and sort of track them, right? So the ability to count and actually have a metric and say this is accurate and counting the number. So this is counting only the objects in the frame. If you have multiple types of animals, for example, right, is he going to be able to count separate? Let's say you have dogs and cats, right? So that those are some of the things that you guys should consider. I think that this is a good start, but there's still a lot of things that you can do to improve it. So that's all I'd say. Yeah, thanks a lot for the work and for the presentation.
Yeah. Thanks, sir.
Thank you, sir.
Okay, thank you. So, Dr. Biodun, any comments?
Oh, I'll give a comment on this, and it's probably a little bit of a general comment too. A lot of what you're doing right now is you're playing in like the early stages of data modeling, doing some statistical work. But as you're picking your project, also think about the world that we live in now. Thankfully, we have information. Information lets you all know that we are in an artificial intelligence era. It's a world that has models that are very, very capable. We have models that are multimodal. They can do text, they can read text, numbers, they can read pictures, they can also see. Excuse me. They can read text, they can see images, they can analyze videos, they can also decrypt sound and understand sound. My suggestion is when you're picking a project, ask yourself, can an AI model do this? What can an AI model not do? Or what can I do that can take what an AI model do already or does already and take it even one step further? And how can I build something around that? That makes your project cutting edge. I look at a lot of these things and I'm like, there's a vision API can identify this and count it as many times as possible. While it is good to understand how that works, a lot of that lesson may be de-emphasized in the future. So that's all I would like for you to think about. I like the fact that you're thinking through how these things work, but then try to map your project towards cutting edge is my only feedback.
All right, sir.
Thank you so much, sir.
Thank you very much, sir.
Okay, thank you for that. So, the last team for today, that's Team GitOps, in the person of Oluwafemi Abiono. Oluwafemi Abiono, are you ready for your presentation? Team GitOps. Oluwafemi Abiono for Team GitOps. Are you ready for your presentation? I can see you are on the call. Oluwafemi Abiono for Team GitOps. Are you guys ready for your presentation? We have no response from you. So, and with that, we have come to the end of our presentations. So any final words for our interns regarding their performance so far? Dr. Wale.
Yeah. So I think there's someone. Was that GitHub?
Yes,
Okay.
I don't know if I'm audible, but I've been having issues with my network, so I've been on and off.
I think we can hear you now. You're audible.
All right, so I'll be sharing my screen now. Okay. I would like to confirm if my screen is up.
Yes, we can see your screen.
Recording in progress.
All right. So very quickly, Olufemi Abiono representing Team GitHub, and our project was to evaluate the prevalence of malaria in Africa. So I will just quickly move to the problem statement. So basically, we are trying to build a predictive model for malaria incidence.
Is there anyone else from that team that can actually pick up the presentation? I mean, because a lot of people are, you guys have put in work into it. I think it would be nice for you guys to still be able to present. So anybody else from the team that can actually go ahead with good network and present or no?
Anyone from Team GitOps? I don't think there's anyone currently on the call that can.
I'm guessing they're streaming from somewhere else. Can they join the call?
Yeah.
I mean, I'm actually just being considerate, because if I look at it, they've had like 10 people and they've worked for weeks or months on it, right?
Yeah, I
We can
understand.
accommodate them. That would be nice. Yeah.
I can make an announcement on the Slack channel for them. Mute. I made an announcement already, so I say we can give like 5 minutes to see if anyone turn on.
And I think before anyone, like, I can just go ahead and so that we don't have to do this again. Just final words. Yeah, I think so far, I think the presentations are really good. I think you guys are putting a lot of work to first find a project, work on it, understand the problem space, and create solutions to them, and also train models and algorithms to further support some of your initial hypotheses. So that's great. Some of the feedback and the advice is that even beyond the technical solution and beyond the modeling and all that, I think it's very important for everyone to sort of think about the environment, and by extension also think about the world, right? Is that this solution that I'm trying to build, how does it even benefit someone? How does it benefit my immediate environment? How does it benefit the world at large? What are the extra enhancement that I can make or add to this project that would actually make it better? What are some of the things I need to consider, some of the qualitative analysis that I need to do if, for example, I'm building something and someone from government wants to use it? What are the sort of qualitative measurements, or what are the things that I will tell them that based on my model, this is some of my conclusion, and these are some of the data that I can use to implement that. So I'd say just think beyond the technical capabilities and think about how this can be used somewhere as a product or to support organization. So that's one thing. And then the other thing is, don't stop here. You guys have already started. If you want to, you can publish the paper. You can put your result on GitHub. You can write a Medium article on it. Try as much as possible to expand what you've done so far. And I think, yeah, the sky is the starting point. Thank you.
Thank you very much for those kind words. Dr. Biodun, your last words for the interns also.
All right, hold on. Well, first and foremost, I would say that every time we have sessions like this, it seems like the level of maturity of the interns and the cohorts continues to get better. And I'm glad that we're continuing to see that. I enjoyed all of the content from the presentation. And to add to what Wally had mentioned, make this into a blog. The only reason I'm adding to that is because I fully believe in it. Put this into a blog and try to connect what you're doing towards cutting edge. There is like the biggest opportunity to make the biggest impact in the world right now, and it's around what you all are doing currently. AI. AI is going to be like the next the buzzword for several years from now. And what you're doing is at the core of AI. So my ask is reflect and find out how can you be a part of this new AI world. You're already doing things around it, but just start thinking about, hey, how do I start interfacing with these APIs? How do I start getting data from these models that are out there? What can I build, or how does my project enhance AI? What is responsible AI? Like all of that is what you all should start thinking about, because it's at the core of what the world looks like, or what the world will look like in many years from now. I'm really proud of the work that you have done. The one addition that I will say though is the quality of your slides could be better. Sometimes aesthetics makes the difference. So work on your aesthetics in your next presentation. Make it colorful, make it more legible. There are cases where I had to strain my eye to see some of what you all are putting, but those little details, while they're not so significant to some audience, that might just be the deal maker. So great job, and wishing you all the best, and continue to push on this data and AI path. Thank you.
Thank you very much for that. So, anyone from Team GitOps, while our judges were talking? You're just eating. Follow. Anyone from Team GitOps? I don't think any of the team members are here. I think we can go ahead and round up. It's an unfortunate event, but it is what it is. At this point, sorry?
I have a question.
Okay.
Abdulaziz. Yes. So it's for the judges. So as a data scientist, I'd like to know how, while making our research, we do find qualitative data, and these data are actually very, very difficult to convert to numbers. So how do we go about merging quantitative and qualitative analysis of data in order to provide something that we can build a model out of? So yes, so I don't know techniques and maybe ways around methodologies around doing so. Thank you.
All right. Dr. Wale, if you could please indulge us and answer that question.
I'm not entirely sure that I got that. Can you do you mind sort of recapping what your question exactly is? That when you have qualitative data, how do you go about?
Okay, yes, because sometimes when you need features to when you need to create features, you need to feature engineer things in order to create a model that is fit to make some kind of prediction or anything you want it to do. You probably will have to come across things like qualitative data, which are very, very key into creating those features. And and this feature, because it's a model, they have to be converted to numbers or vectors. So how do we, what are the methods you think we can actually use to extract quantity out of qualitative data?
Okay, yeah, I see what you mean. I mean, your question is basically a classic one semester NLP course, which is when you have qualitative, in this case, I think you mean sort of more structured data. How do you sort of extract that information and make it ready or include it as features in your model, right? So there are a lot of different methods that you can use. I can take text, for example, right? One of the things that you can always do is that you can find a way to represent your text and create a vector representation for them. So there are different methods that you can use. The TF-IDF, bag of words methods. You can also create embeddings for them. These vector embeddings actually sort of represent it. So you can do that. You can use different things. But also I've seen cases where there's some sort of hard-coded methods that you can use where, if this text contains this word, then 0. If it doesn't contain it, then 1, right? So also, but for that you need to have a much more understanding of the data and what you're looking for, right? So what in summary, there are just so many things you can do, so many technical methods. Some of them are manual, some of them are automatic, that you can use to convert qualitative data into sort of numerical values or vector representations and put them into your machine learning models, right? But it depends on the use case and it depends on what you're looking for. And so that goes back to understanding the problem space and why you will need that piece of data at first. I think that would help you make that decision.
All right, thank you. So the last question is, after this program, what do you think the advice you can give for someone in pursuit of a data science career? What do you think they should do next? What kind of advice can you give someone in the data science?
Yes. I'll take this, and also I think it's really nice for my my colleague to also give advice. I mean, so after this, right, is you just keep building. I know sometimes, right, certifications and doing programs are very important, but what happens after you're done, which is all the things that you've learned, all the lessons that you've done, even all the projects that you've worked on. Can you take them? Can you enhance them? Can you work on some other projects? Some other projects where maybe you don't even need to get data from Kaggle, you need to source your data. Can you think of some immediate problems in your community around where you are in your country? Can you think of something, right? So building, I think the next step for me, I think, is just building. And then when you build, don't be shy about showing the world your work. And I say don't be shy, that write blog post on Medium about what you've done. Clean your code, make sure your code is nice, make sure it's really good, put them on GitHub. Put those GitHub link and those Medium link on your resume, right? And that's how, I'm giving you this example because this is exactly how I started my career. I started off writing blog posts, working on projects, building stuff, putting things on my GitHub, and just keep improving. So I think that's, building a data science career is about solving problems, but also having the ability to actually communicate your solution. And you communicate your solution, the technical aspects, by making sure that you put readable, clean, executable, reproducible code on GitHub that other people can see or reuse, for example, and also communicate to other people by writing, blog posts or publishing a paper around it. And that is one way to gain visibility. Yeah.
Thank you very much.
Okay, thank you very much for that. Before I allow Dr. Biodun to give any comment, yes. Oluwafemi Abiono, are you on the call? You say your network is stable and you can present now. You'll be given just 5 minutes for presentation if you can. Oluwafemi Abiono, you sent me a direct message. Are you on the call? I think his network is still malfunctioning. So, Dr. Biodun, do you have any comments you want to add before I round this?
Yeah, just a few additions to what Wale had mentioned. My recommendation is try to align yourself with, on top of creating blogs, putting your work out there. I'm going to say the word AI again, because I truly believe that that's one of the areas where you all can continue to learn. See AI as one of your learning paths. Familiarize yourself with a lot of models. Here's what's unique about AI. A lot of the models that you all will get to play with are all going to be built in the cloud. Nothing is going to fast track the creation and production of high-powered computing more than artificial intelligence, because processing large sets of data, running AI models requires high-powered computing. And where do you see a lot of these high-performance computing machines? They are all in the cloud. That is to say that if you don't have experience using any of the cloud providers, I would not name names, but all the biggest hyperscalers like Microsoft, Google, Oracle, AWS. If you can learn one of those high-powered computing platforms and learn how AI works in any of these high-powered computing platforms, and maybe get a certification to say, hey, maybe, for example, Google has Vertex AI Workbench. How does that work with TPUs? How do you do AI in that framework, and playing with it and making sure that your projects have some form of cloud presence? You're not only doing the rudimentary, you're also at the cusp of what many professionals out there are using, which makes you have a lot of brand equity and value for prospective colleagues, prospective employers, prospective folks who want to work with you and partner with you. So that's the next part that I would like for you all to focus on. Focus on playing with cloud technologies with regards to artificial intelligence. Focus on building a lot of what you're building now in the cloud, because that is where the world is going to, and a lot of the advancements and innovations around AI is going to all emanate from what's in the cloud.
Okay,
That's
thank you so much for that advice. At this point, I'd like to say a big thank you to all our presenters, all teams, and our judges, Dr. Wali and Dr. Biodun, for a very successful session. The entire Amoye team feels privileged to have had you joined us for a culmination of an intense 4-month journey in the realm of data science. We are eagerly anticipating and witnessing your remarkable assets into your chosen domains, and that is for our interns. So please take note of the following. The results of the grand finale presentation will be completed and published on Slack next week. The internship officially comes to an end on Tuesday, December the 19th, 2023. And congratulations to you all that have partaken in this internship from the start till finish. We aim to have your certificates ready by the first week of the new year. If you fulfill all qualifying criteria, you can expect to receive your certificate via email. Any more announcements will be made on Slack. On that note, it's a goodbye from me. Do enjoy your rest of the weekend. Season's greetings from us to you, and we hope you have a wonderful and well-deserved holiday break. So, bye bye, everyone.